Good morning. This is Unit 6, Day 6 notes, and we're going to work on standardizing the normal distribution. So we have this formula to find the z-score, and then we have a chart that we can look up to find our probability. So this is the score that you're trying to find minus the mean divided by the standard deviation. Remember, this is our curve, our normal curve. So let's look at this. It says standardizing any normal distribution. Given x as a normal variable with mean 62 and standard deviation 7, find by first converting to standard variable z, then using your GCD and interpret each result. GDC. Okay. So they want us to find first using the formula, which is the probability of the z-score is less than or equal to, this one is 69. So 69 is my score minus, my formula says we're going to subtract the mean, which in our case is 62. And then we're going to divide that by the standard deviation, which is 7. All right, so we can put this into your calculator. All right, I'm going to show you how to put this in your calculator. So you're going to go to second vars, and we're going to press number 2 for normal CDF. And on my calculator, it doesn't have the next screen. On your calculator, it should have like a different screen. But if you have a calculator like this, we're going to put -1 and then e to the 99, which means like negative infinity, comma. And when you put this in your calculator, 69 minus 62 is 7, divided by 7 is 1. So we're going to go to 1, and then I'm going to close my parentheses, and my probability is, it's 84, 0.8413. Okay? Now, what you're going to do in your calculator, your calculator will do all this for you. You can skip this part where you're trying to find the z-score. So my calculator is not as updated as yours, but I'm going to show you what to do. You guys are going to go to second vars, number 2, still CDF, and you're going to put in the calculator. It's going to ask you, you guys are going to have a different screen, and it's going to ask you, the first one, my lower bound, is going to be -1. Second comma is this E99. And then it's going to ask you for your test score, which is 69. It's going to ask you for your mean, which is 62. 62, comma, and then it's going to ask you for your standard deviation, which is 7. If you just plug all those into that screen, it'll actually give you the same number. So this is a 84.13% chance that a randomly selected observation is less than 69. Now, if we want our observation to be greater than 54.3 with the same parameters, the same mean and standard deviation, you guys are going to go back to your calculator, and I'm just going to copy this, go up here. It won't let me. Okay, so second vars 2, and this time it's greater than 54.3. My x is greater than 54. So my lower bound this time is 54.3. My upper bound is going to be infinity. So we're kind of switching these. Upper bound is infinity, so 54 to infinity. My mean and standard deviation are going to stay the same, 62 and 7. This one will give us an 86.4%. I want you guys to try C. Please pause your video and try C now. The lower bound is 58.5 and the upper bound is 71.8. Your mean and standard deviation should be the same. You shouldn't even have to change it. You should get about 61.07% chance. This one says, Casey is collecting donations for the Reston Youth Triathlon by mail. The average weekly collection is approximately normally distributed with a mean of 40. So this is our mean, is 40. Sorry. And the standard deviation of $6. What proportion of weeks would she expect to collect between $30 and $50? So my lower bound is going to be 30 when I put this in my calculator. So we go to second vars, and I'm going to press number 2, and our lower bound is 30. Our upper bound is 50. My mean is 40. Sorry guys. So the mean is 40, and then the standard deviation is 6. When we plug this into our calculator, we get 0.904. So that's like 90.4%. At least 50 means that my probability of X is greater than or equal to $50. Or 50 is my lower bound, so we're going to put lower is 50. My upper bound is infinity. So what we do is you can write E99, and that means like 10 to the 99 power, or infinity. And then we're gonna have still the mean and standard deviation should already be in there for you. Just press or go down and press enter. And then when we plug this into our calculator, we get 0.04779, something like that. So that's about 4.7% or 4.8%. I want you guys to try number 3. Remember, to find the z-score, we actually have a formula for that. They want us to find the z-value. So for this one, just make sure you use your formula. The formula for this, for your z-score, is your score minus the mean divided by the standard deviation. Alrighty guys, let's go ahead and go to inverse normal distribution problem. So it says to find the x value or the z value associated with a particular probability, use the inverse normal distribution. There's actually, I think that's number 3. It says z is a standard normal distribution. Illustrate, then find the value of k. We're going to use our calculator such that the probability of z is less than or equal to k is equal to 0.81. So they want us to actually illustrate that. I'm going to show you kind of what it looks like. Oops, kind of. And this is my normal curve, okay? And we're going to say this is k because the probability is about 0.81. So this is k right here. And this area underneath this curve is what we're trying to find. So we're actually going to use our inverse norm. That's what it's called on your calculator. So you're going to go to second vars again, second vars, and it's number 3. Second vars inverse norm. It's asking you for the area. This area under the curve is right here. They give you the area. So your area you're going to plug in is 0.81, and then it has your mean is 0 and your standard deviation is 1. We're not going to change that. They didn't give us any parameters for that. So just press enter, enter, do it again, and you'll get K equals 0.87789, keeps on going, okay? All right. Now let's try B. On this one is very similar. We're just going to plug in the area. The area in this one is 0.58, and then just keep on pressing enter, and you're gonna get your K value is 0.2018. So I'm going to put 2. This means that your K value is 0.202. If K is right here, it's not changing colors. Okay, if K is right here, and then this shaded area underneath the curve is 58%, and this value K is 0.202. Alrighty, I think you guys can try the rest. I actually want to try these for you because these are different. So this one says Z is greater than K. Well, when we plug it into the calculator, we're finding where it's less than K. So if Z is greater than K, then if K is right here, and Z greater than K, the area underneath this curve is something like 83%, then what we need to plug into the calculator is where it's not. We want this part right here, which is 17%. Just subtract that from 100. So this is 17%, or subtract this number from 1. So what we need to put in our calculator is the probability of Z is less than or equal to K. And then put 0.17. So when we go to second bars, press number 3, your area you need to put in there is 0.17. Everything else should be the same. And your K will be accurate. It's negative because it's on the left-hand side of the mean. So this is negative 0.954. All right, this one is a little tricky also. I want to go over it. We have a normal curve, and we are trying to find out which K will give us our probability, or our area underneath the curve between negative K and K will give us an area of 0.62%. So maybe this is negative K and this is K, will give us this area in between has to be 0.62 or 62%. What I'm going to do is I'm going to find the probability that Z is less than or equal to K, okay? Which is how I'm going to put in here. So I need to find out what the area is of Z just being less than K. So I'm going to find out this whole area less than this K right here, right? Well, in order to figure that out, I know this is symmetric. This area is equal to this area. So I'm going to do 62 divided by 2, which is 31. So this right here is 31. We know this is 50%, including all the way to negative infinity, is 50%. Well, 50 plus 31 is 81. So I'm just going to find the area underneath the curve between negative infinity and 81. 81 is my area. That's my percentage. So when we plug this into the calculator, we're going to plug in 81, or 0.81, and enter, and we're going to get that K is equal to 0.87. Keeps on going, or 78, okay? So this K is 0.87, okay? But this is 81%. Okay, well, if this one is 0.878, then negative k is negative 0.878. 0.878, right? If k is this, negative k is negative this. You can always try it, check it, and see if it works. Go to regular CDF when our lower bound is negative 0.878 and my upper bound is positive 0.878, and see if the area underneath that is 62% or 0.620. It'll work. So my x is greater than negative 0.878 and less than 0.878. And see if that works. This is the last one I'm going to try today. Try the other ones and let me know if you have any questions. Have a wonderful day.